Welcome to Wiki Lectures. So, in the previous class, we have studied the Coulomb's law in point charges as well as charge distribution. So, now we will see what is electric field. So, uh, if a charge Q and a small charge Q is separated by a distance R, the force between them, according to Coulomb's law, the force between them or force acting on Q due to another charge capital Q is given by kq small q divided by r square and r cap. This is the direction of the force r cap. So if we are taking this q in left side, fq divided by q will be equal to kq by r square into r cap. So what does it mean? That is the force experienced by, so here the force experienced by the charge q is given by this expression, while the total force experienced divided by q is given by this expression, which means the force experienced by a unit charge. Here we have divided by the charge q, so it is a force for a unit charge only. So the force experienced by a unit positive charge is termed as electric field intensity, or simply electric field, or simply it can be called as electric field. So this is the electric field. The force experienced by a unit positive charge is called electric field intensity or electric field. So electric field E is represented by K Q divided by R square into R cap, which means if you are having a charge Q, there will be a field around this, there will be an electric field around this, and at a point here at a distance r from the charge q, there is an electric field which is given by E is equal to kq by r square, and this is the direction. If this is the direction of r, just given by r cap, the direction is given by r cap. So this is called electric field intensity of a charge q at a point of distance r from charge q. Okay, here we are considering two types of charges, that is positive charge and negative charge. In case of positive charge, q will be positive, so E is equal to kq by r square. That is, the electric field is diverging, which means it means the electric field is diverging. You can represent like this: if there is a positive charge here, it is positive, electric field is positive, which means electric field lines are coming out of the charge. This is called diverging field. It is called diverging field. And if the charge q is negative, there is an electric field which is negative. Negative electric field means, this is the charge, negative electric field means the field lines are into the charge. Field lines are into the charge. This is the representation of electric field here. So this electric field can be represented as a converging field. It is a converging field. These two cases can be represented mathematically as, this diverging field can be represented as, diverging field means it is q is positive, it is diverging field, and every positive charge like act as a source. So this is a source. Field lines are coming out of this point, positive charge, so it can be called as source, and this can be called as a sink, because the field lines are coming into this can be called as sink. The source charge, positive charge or source charge, can be represented as a diverging field, as it is a diverging field. As you know, the divergence can be represented if a vector is there, its divergence can be represented as del dot A. So here the vector is electric field, so del dot E will be there. This is the divergence. So this divergence can be represented as rho by epsilon naught. This you will study in the section of Maxwell's equations. And if there is a negative charge, del dot E will be equal to minus rho by epsilon 0. So the divergence is negative, which means converging. Okay, clear? electrostatic field has some properties. Electrostatic field means the charge is at rest. Then it is called electrostatics. So what are the properties? It is a conservative field. And second one, work done by a unit charge. That is, work done can be represented as always work done is equal to force into distance. So here, for a unit charge, force will be equal to electric field. Force will be force experienced by a unit positive charge, electric field E into dl. dl is the this distance. So what is the work done? W is equal to for a path from A to B. If the initial point is A and final point is B, then integral A to B E dot dl, which means it is independent of the path followed. It will depend upon only upon the upper limit B and lower limit A. So it is independent of the path followed. And the next property is closed line integral E dot dl. So this is the work done by a unit charge. It is independent of the path followed. Then if there is a closed path, means it will start or it will end wherever it starts. Okay, so the end point and starting point both are same, that is the limits are same. If the limits are same, it will be 0. That is closed line integral E dot dl will be equal to 0, which means it can be converted as a surface integral by using Stokes theorem. As you all know, if there is a closed line integral, it is a line integral. If there is a closed line integral, it can be converted as a normal surface integral as del cross of vector. This vector, del cross of that vector dot ds will be equal to right hand side 0. So this is expression. This integral line integral can be, this closed line integral can be converted as a surface integral, which implies del cross E dot d is equal to 0, which implies del cross E equal to 0. What is this meaning? Del cross E is equal to 0, which means this vector is irrotational. This vector is irrotational. So these are the points that you have to remember. Then coming to the force expression, of force, that we say that a unit positive charge. If there is a unit positive charge, the force experienced by the unit positive charge is represented as E. This is for a unit positive charge. For a unit positive charge, F is equal to E. But if there is a charge Q, commonly how we will write that? F is equal to Q into E. How we will write like this? If there is a charge Q and small q is there, the distance r, then according to Coulomb's law, the force will be equal to k into q divided by r square into r cap. Then these terms kq by r square into r cap can be represented as E. Then what is remaining? Small q only. Is it? F is equal to small q into E, that we have written here. F is equal to q into capital E. Here this q, point charge q, may be positive or may be negative. Q may be positive or negative. If q is positive, then F will be equal to plus q into E. And if q is negative, force will be equal to minus q into E. So if this is positive, then the force, the direction of force and the direction of electric field are same, that is parallel to each other. If if q is positive, then E and F are in same direction, that is F is parallel to E. And here is a minus sign, so the direction of electric field and the force will be opposite to each other, that is F is anti-parallel to E. Here F and E are in same direction, here F and E are in opposite direction. That is, if this is the electric field and here is a charge plus Q, then there will be a force in the same direction. There will be a force acting on Q due to E in the same direction. which means a positive charge, which means a positive charge placed in E, a positive charge placed in E will move in the direction of E, in the direction of E. Due to this E, there is a force acting on positive charge Q in this direction, which means a positive charge placed in E will move in the direction of E. Then in the second case, if we are having a positive, if we are having electric field here and there is a negative charge minus Q here, what will be the force here? Force will be in opposite direction. Force on Q minus Q due to E will be in opposite direction. What is this meaning? Which means a negative charge, placed in electric field will move opposite to E. It is having a force along this direction, opposite to E, which means a negative charge placed in electric field will move opposite to E. Coming to the applications of the previous concept. First applications. So the first one is a simple pendulum placed in an electric field. So in simple pendulum, here this is the first case that we are considering. So the electric field from positive to negative, electric field will be from positive to negative. So if this is a positive plate and this is a negative plate, there will be an electric field in this direction. Okay, and if this is a condition that this is a simple pendulum, and if it is in this position, there will be a gravitational pull here, that is a gravitational force mg will be here in downwards, and also the electric field is in this direction, also electric field also in the same direction. So this charge q, this ball of charge q will experience a force due to this electric field E in the same direction. This is a positive charge, so in the same direction, that will be equal to Q into E. So there is two forces, that is mg and Q will be there. So the total force F net will be equal to this mg plus Q into E. That is total force Ma will be equal to mg plus QE. Therefore acceleration A is equal to dividing throughout by m, g plus q e by m. So this is the acceleration, total acceleration here. So we'll directly go to the time period expression. This is a time period of simple pendulum without any field, t equal to 2 pi root L by g. So g is the total acceleration acting here. Here without any field means acceleration is g only. So we are replacing this g with what the acceleration that we are getting in this case. So this is the acceleration here. So the time period will be t is equal to 2 pi root L divided by g. Instead of g, the acceleration will be g plus q e divided by e m. So this is the acceleration, this is the time period in the first case, simple pendulum placed in electric field in this manner. So what is we'll represent this by t dash, and this is t. So comparing these two expressions, we can see that t dash will be less than t, which means time period decreases. Time period decreases, which means the pendulum runs faster. Time period decreasing means it is moving fastly. The pendulum runs faster. So when a simple pendulum is kept in electric field like this, the time period will decrease or the pendulum runs faster. As a second case, so this is the first case. As a second case, we are considering the same simple pendulum. We are considering the same simple pendulum in a different manner, which means this is the sorry, we are considering this is the second case. The electric field is in same direction. The electric field E is in same direction, but here is a change that we are taking a ball of charge minus q to oscillate as a simple pendulum. So if this is minus q, the gravitational force will be same towards downwards only. This is mg will be same. But what about the electrostatic force acting on minus q? Electric force acting on q will be equal to, it will be opposite to E. If the charge is negative, the force acting on q, force acting on this negative charge due to E will be opposite to this electric field. So this will be equal to, F is equal to minus q into E. This is the total force here. So what is the total force? This is mg here and minus QE here. So F net will be equal to mg minus, mg is in this direction and q is in opposite direction. So mg minus q into E. mg minus q into E. So what will be the m into A? Total force will be equal to m into A will be equal to mg minus QE. Therefore, A will be equal to, dividing throughout by m, g minus QE divided by m. QE divided by m. Therefore, the time period here, T dash can be expressed as equal to, T dash equal to 2 pi root L by g, or L by acceleration. L divided by, what is the acceleration here? Acceleration will be equal to g minus QE divided by m, which means from here T dash is greater than T. It is the case without any field, 2 pi root L by g. So here there is a minus term in the denominator, which means T dash increases with respect to T, which means the time period increases. Time period is increasing means the pendulum moves slower. The pendulum runs slower compared to the normal case without any field. Okay, and here we are having our third case, that is, this is a simple pendulum. This is a simple pendulum and electric field is in this direction, x direction only, electric field. So what will be the, what is the gravitational force? It is normally in this direction only, mg only. But what about the electric field, electric force? If the electric field is in this direction, and q is a positive charge, the force will be along the same direction. That is, F is equal to q into E, will be in x direction. So this is in minus y direction and this is in x direction. So there are two forces acting on perpendicular to each other. There will be a resultant force. So there will be a resultant force between these two that will be equal to, F net will be equal to square root of, that is our source, mg square plus QE square. How we will get this expression? This is the expression that you have already studied. How two forces, two vectors can be added if they are having an angle 90 degree between those two vectors. The resultant vector will be equal to square root of mg square plus QE square, which is equal to root of m square g square plus q square E square. This is nothing but m into A net, or total A. So A will be equal to, or A net will be equal to square root of, so m can be taken this side. So inside this square bracket, m will be act as m square. So m square divided by m square will be cancelled. So g square plus q square E square by m square. So this is the net acceleration, and t dash will be equal to 2 pi under root L by this a net. Net force will be, net acceleration will be this one. So this is the magnitude of acceleration. And what will be the resultant vector direction? If this is the direction of resultant vector, resultant force vector is in this direction, which makes an angle theta with y component, then how to get this direction? That direction can be represented as tan theta will be equal to y component divided by x component. Y component of force divided by x component. What is the y component force? That will be equal to mg. Not mg, it is minus mg because it is minus y. Y component is minus mg divided by what is x component? X component is q into e. So this is the tan theta. This is the expression for tan theta. Therefore, theta will be equal to tan inverse tan minus mg divided by qe. To remove this minus sign, it can also be represented as pi by 2 plus tan inverse mg by qe. So this is the expression for the angle between the resultant vector f and the y direction. Okay. So this is the second application for a point charge. If we are having point charge q here, and at a distance r, we need to find the electric field. At a distance r, we need to find electric field. So what is electric field? If you are placing a unit positive charge here, what is the force acting on this unit positive charge? Is it? So this is a simple expression that electric field E will be equal to kq divided by r square into r cap. This is a simple expression. And coming to the second case, there is a charge plus q and minus q separated by a distance 2d, and from this, so this is 2d, and this from the center at a distance x we need to find the electric field. So as this is the center, this distance will be d and this will be also d. So at this point we need to find the electric field, which means considering here we are placed a unit positive charge. Consider a unit positive charge is placed at this point. Okay, so we need to find the force on this unit positive charge due to this plus q as well as this minus q. So first we need to consider only one charge plus q. At this point we are going to find, so at this point what will be the force acting on this unit positive charge due to plus q? This is a positive charge and this is also a positive charge. The force will be acting this direction. That force can be represented as E only. E is equal to K into capital Q divided by what is the distance between this point and this point? Here, this up to here it is x, and this is x plus d. So this will be equal to ex plus d whole square. So this is the direction and this is the magnitude. So by considering this minus q, now we are going to consider this minus q, then what is the force between this minus q and positive charge? This will be attractive force. So towards this minus q, there will be a force or electric field towards this minus q. So what is the magnitude? E will be equal to k q divided by what is the distance between this point and this point? The total distance is x up to here, and minus d will be this distance. So x minus d the whole square. So these are the forces acting on right towards right and towards left. So what is the total force acting here? What is the total force? E will be equal to, we are just considering this as as E1 and this is E2, then what will be the total E? Total will be equal to E2 minus E1. E2 in positive direction, sorry, right direction, and E1 in left direction. So what is the net effect will be the difference between these two? So E2 minus E1, which will be equal to KQ divided by x plus d the whole square minus KQ divided by x minus d the whole square. which will be equal to the KQ can be written outside. The remaining terms will be 1 by x plus d the whole square minus 1 by x minus d the whole square. So which will be equal to KQ into cross multiplying these terms x minus d whole square minus x plus d whole square divided by x plus d whole square into x minus d whole square. Okay, which will be equal to, so I will write here, which will be equal to KQ into, what is this, x minus d whole square, a minus b whole square will be a square plus minus 2ab plus b square. So x square plus d square minus 2xd will come, minus here also x square plus d square plus 2xd. So x square plus d square here, x square plus d square here, there is a minus term which will be cancelled. Then here will be a 2xd here, minus 2xd here, here also minus of 2xd here. So what will be the total effect? Minus 4xd divided by, here this is a square, this is a square, so we can simply written it as x plus d into x minus d the whole square. X plus d into x minus d the whole square. So what is x plus d and x minus d? A plus b into a minus will be a square minus b square. So this will be equal to x square minus d square the whole square. X square minus d square the whole square. So this is what we are having. This is the final expression that we are getting. And how we have taken this E2 minus E1. E2 means in right direction and E1 in left direction. Right minus left we have taken. So this is in I cap. Right minus left means this is in I cap. So which will be equal to, we'll write it once more, minus 4k q xd divided by x square minus d square the whole square in I cap, or this is the total force acting on negative direction. Minus I cap is the direction actually. So as we taken E2 minus E1, this is the next direction and we are having a negative sign. So this is the total force acting on in this point. Total electric field acting on this point due to this plus Q and this minus Q. Okay. So this is another case. Here we are having a charge plus Q here and a minus Q here, which is separated by a distance 2d and a distance z from the center of this plus and minus Q. We need to find electric field. So what is electric field? We are considering this, there is a positive charge here, there is a unit positive charge here, and we are finding the force. That's all. So at this point we need to find the electric field. So this is a unit positive charge here, there is a unit positive charge here, and this is a plus Q. So what will be the force acting here? It will be repulsive force. So this is away from the charge. Resultant force will be away from this charge. So what is the force or electric field? E will be equal to K Q divided by this distance. What is this distance? If this is D, 2D is divided into D here and D here. So this is D and this is Z. Then this is the hypotenuse, which will be equal to square root of Z square plus D square, or D square plus Z square. So this square of the distance will be D square plus Z square. So we got electric field here. So this electric field can be resolved into two components. If this angle is theta, this angle will be equal to theta and this will be equal to theta. So this is E cos theta component and this is E sin theta component. This can be represented as E1. So this E1 sin theta and this is E1 cos theta. Okay. And what is the second force or second electric field? Electric field due to minus Q. if this is a positive charge and this is minus q, the force will be towards this charge, or electric field will be towards this charge. Okay, this is the electric field acting here. Electric field E2 will be equal to k q divided by the distance between this positive charge and this negative charge will be the same, z and d. Here also square root of z square plus d square, so the square of that, square root of d square plus z square. So this is E2 electric field. Here also we can resolve into two components, this one component and this is another component. So if this angle is theta, this angle will be also equal to theta. So this component is cos theta component. This is E2 cos theta component and this is E2 sin theta component. Okay, so E1 cos theta and E2 cos theta. E1 and E2 are same. Both the thetas are same. Therefore, E1 cos theta and E2 cos theta will cancel each other. These two will cancel each other. So what will be the total force, total electric field E net will be equal to E1 sin theta plus E2 sin theta. As E1 and E2 are same, 2E sin theta, which is equal to 2, what is E? KQ divided by D square plus Z square into sin theta. What is sin theta here? If this is theta, sin theta will be equal to opposite side by hypotenuse. So D divided by root of d square plus z square, which will be equal to 2kqd divided by d square plus z square all raised to 3 by 2. So this is the net force here. Coming to the next problem. Fourth problem. Here we are having a square. Is a square, consider it as a square, and in the corners of the square here is a plus q, here minus q, here q, and here we need to find the electric field. We need to find the electric field means we are going to place a unit positive charge here. So we can consider here is unit positive charge. So this is a a a. What will be this distance? If it is a square of sides a, then this diagonal will be equal to root 2a, will be equal to root 2a. Okay, then first we are considering this q. Due to this charge q, there is an electric field acting on this positive charge. So this is also positive charge. The force or electric field will be in this direction, away from the q. So this is the first force acting here, that can represent it as E1 will be equal to kq divided by the distance a square. So the next force, this is a minus symbol, minus charge q. So when we are considering unit positive charge here, it is an attractive force, or this, as it is a opposite charge, it will act towards the charge. So this is towards there is an electric field. This is called E2. E2 can be represented as E2 equal to kq divided by a square. So this is also kq by a square. Okay, so these are the two forces acting now. Then we need to consider another force. Another force means in this direction, in this diagonal direction. This is a plus 1 charge here. This is a positive charge, so it is away from the charge, just opposite to that line, away from the charge. This is a force force acting here, or it can represent it as electric field. E3 will be equal to kq divided by this distance is root 2a. So root 2a the whole square means 2a square. So this is E3. So we know we are having these three cases, and when we are considering this E1 and E2, these are perpendicular to each other. Therefore, there is a resultant force in this direction. Due to this E1 and E2, the total force will be equal to, since if E1 and E2 are perpendicular to each other, there will be a resultant force acting on this direction due to E1 and E2, which will be equal to square root of E1 square plus E2 square, because as it is right angle to each other, the resultant will be equal to E1 square plus E2 square. So this is the total force due to E1 and E2. So we will find that one. E12 will be equal to square root of, what is E1? E1 is KQ by A square is E1. E1 square plus E2. E2 is also KQ by A square, the whole square, which will be equal to KQ by A square is here, KQ by A square, 2 times KQ by A square the whole square, root of 2 times KQ by A square the whole square, which will be equal to root 2 into KQ by A square. So this expression is equal to root 2 into KQ by A square. If this is a resultant force, and this is this is a resultant electric field, and this is E3, this E12 and E3 are in right angle to each other. If this is the diagonal, in this diagonal direction, this direction and this direction, the resultant E12 direction and E3 direction will be perpendicular to each other. So the net force, total force acting on this positive charge, net force, not net electric field. Net electric field will be the combination of E12 and E3. So it will be equal to square root of, what is E12? E12 is root 2 KQ by A square. So first electric field square plus, what is the second electric field? KQ by 2A square. KQ by 2A square the whole square, which will be equal to root of 2 KQ by A square the whole square plus KQ by A square the whole square into 1 by 4. 1 by 2 the whole square will be 1 by 4, which will be equal to, this KQ by A square can be taken outside. KQ by A square can be taken outside. What is remaining? Square root of 2 plus 1 by 4. 2 plus 1 by 4, which is equal to 4 plus 2. Cross multiplying, 4 into 2 will be 8. 8 plus 1 will be 9. Root of 9 divided by 4. Root of 9 divided by 4 means equal to root of 9 by 4 KQ by A square, which will be equal to 3 KQ divided by 2A square. This is the final force. So what we have done here we have considered first E1 and E2, then we have taken the resultant of E1 and E2 in this direction, and there is an E3 here. So this resultant and this E3 is in right angle to each other, so we are taking the resultant of these two and we are getting like this. Okay, next we have moved to continuous charge distribution, the electric field on continuous charge distribution. Continuous charge distribution. Coming to continuous charge distribution, we are having a one dimension charge distribution, two dimension is there, and three dimension is there. In case of one dimension, we have already seen that lambda, the charge density, linear charge density will be equal to dq by dx, or dq can be represented as lambda dx. Here in two dimension, the sigma, surface charge density sigma, will be equal to dq by dA, or dq can be represented as sigma dA. And in three dimension, the volume charge density rho will be equal to dq by dV, or dq can be represented as rho dV. And one more thing we have to remember, if the point is symmetric, if it is a symmetric charge distribution, then we are taking two elements we are taking, and half limits we are taking. If we are having a symmetric charge distribution, we are taking only one element but full limit, one element but full limit. So by all these things, remembering all these things, we are moving to a thin rod. A thin rod having charge distribution of linear charge distribution lambda, and here from this center at a distance z we need to find an electric field E. Okay, so this is from minus L by 2 to Al by 2. So in this a thin rod of length L minus L by 2 to L by 2, and from the center at a distance z we need to find electric field. Okay, so here as we find the force, it is a similar way. So this is an element that I am taking at a distance x from the center, and there is a distance z to this point where we are going to measure the electric field. So due to this element dq, due to this charged element dq, there is an electric field at this point in this direction. E1 will be equal to, that is equal to that k into dq divided by the distance square. Distance is, this is the distance, so its square will be z square plus x square. This is E1, and also there is an E2 here which is due to this charge dq, that will be also equal to k dq divided by z square plus x square. These are the two forces. So solving the two components, these two components will be here, here also two components will be there, and as this angle is theta, this angle will be also equal to theta. So this is theta. Also if this is theta, this will be theta, and this will be theta. So these two are cos theta components and these two are sin theta components. So sin theta components will cancel each other. This is sin theta component and this is sin theta component. Both will cancel each other, and the cos theta component will remain. This is also cos theta component. So this is E2 cos theta and this is E1 cos theta. So what is the net electric field? E net will be equal to E2 cos theta plus E1 cos theta. As both are same, we can represent it as 2e cos theta, which is equal to 2 into, what is this E? K dq divided by z square plus x square into, what is this cos theta? Cos theta will be equal to, this is x opposite direction, cos theta. Cos theta will be equal to adjacent side by hypotenuse. So z divided by root of z square plus x square, which will be equal to 2k dq into z divided by z square plus x square all raised to 3 by 2, which is equal to 2k dq can be represented as lambda dx into z divided by z square plus x square whole raised to 3 by 2. This is the E net due to dq, due to both dq's. So this is E net due to dq's. So what we need to find? We need to find the electric field due to this whole line segment. So what will be the total electric field? E total electric field will be equal to integral E net. This is the E net. So we need to integrate this one, which is equal to, we are taking the constants outside, 2k lambda z into integral dx divided by z square plus x square whole raised to 3 by 2. So from where to where? We need to take only half limits. So 0 to L by 2 we need to take 0 to L by 2. So this is a standard integral and the value will be equal to, its value will be equal to z x divided by, its value will be equal to x divided by 2, okay, 2z square into z square plus x square whole raised to 1 by 2. Yes, 2z square into z square plus x square whole raised to 1 by 2 from 0 to L by 2. This is the expression. By substituting, you can substitute these things and you will get an answer like 2k lambda L divided by z into L square plus 4z square all raised to 1 by 2. So this is the answer. How this lambda will come here? Lambda will be equal to x divided by this quantity. X by this quantity will remain, that will be equal to now the next problem is find the electric field at an arbitrary point due to a thin rod. Due to a thin rod. So here we are considering a thin rod. This is a thin rod and at a distance z at an arbitrary point. It is not a center, not a side, just an arbitrary point. So from here at a point at a distance z, we are considering a point. Here we are going to find electric field. Here we want to take the electric field. So how we will find the electric field? Consider that a positive charge, unit positive charge is placing here, then we are going to find the force, that is called electric field. So here we are going to consider dq, a charge element dq. Due to this dq, there will be an electric field at this point. That electric field can be denoted as k dq divided by the distance square. What is the distance? This distance can be represented as square root of x square plus z square. So square of that will be x square plus z square. So this is electric field, and what we will do, we will resolve into two components. These are the two components of electric field. This component, if this is theta, this angle will be theta and this angle will be theta. So this component is cos theta component. This is dE cos theta and this is dE sin theta. So let us take x component. First we are considering x component, that is dEx. X component will be equal to, this is x component, that is dE sin theta. X component is d sin theta, which can be represented as, which is equal to dE. What is dE? K dq divided by x square plus z square into sin theta. What is sin theta here? This is theta. Sin theta will be equal to opposite side by hypotenuse, that is equal to x divided by square root of x square plus z square. Therefore it can be written as k into dq can be changed as, if lambda is the linear charge density, then dq will be equal to lambda dx. So here lambda can be written here and x, then dx can be written here, divided by this term and this term. Total will be x square plus z square whole raised to 3 by 2. So this is dEx, actually this is dEx. So if we are integrating this, we are getting Ex. So Ex will be equal to integral of these terms. Okay, so what will be the integral? Which is equal to k lambda integral x dx divided by x square plus z square whole raised to 3 by 2. This is also a standard integral, so its value will be equal to k lambda into x is a variable and here z is there, so the integral value is equal to minus z divided by x square plus z square whole raised to 1 by 2. This is the answer. This is a standard integration. X dx divided by x square plus a square all raised to 3 by 2 will be equal to minus a divided by x square plus a square all raised to 1 by 2. So instead of a, here we are having z. So this is equal to, so this is our result, and it can also be written as, k lambda divided by x is equal to this expression, which will be equal to, from standard integration, it is equal to k lambda into minus 1 divided by x square plus z square whole raised to 1 by 2. This is the result of this standard integration. So it can also be written as k lambda. We are multiplying and dividing by z to minus z divided by x square plus z square whole raised to 1 by 2. So this is the term. We are divided by z and multiplied by z, which will be equal to, what was our figure? Uh, this is a rod, and at a point z we are measuring electric field, and we are considering a charge element at a distance x. So this is the electric field, and this is the hypotenuse of this triangle, x square plus z square, and this is the theta we have taken. Okay, so what will be the z divided by root x square plus z square? That is nothing but the cos theta according to this triangle. So it can be written as k lambda by z into minus cos theta, Here we need to take complete charge. Only we have taken a charge element. We need to integrate from this end to this end. So here it is not easy to integrate from one end to one end, because it is not an unsymmetric charge, not a symmetric charge distribution, not like our ordinary unsymmetric charge distribution. It is an ordinary point here. That is why we need to consider the angle at which this point makes with the uh, charge element while we are taking the charge elements in different points. Okay, so just consider this figure. It is like this. It is simply like this. If we are having a theta 1 here and theta 2 here, theta 1 is measuring in clockwise direction. What is clockwise? This theta 1 is measuring in clockwise direction. This is clockwise direction. So theta 1 is measuring in this direction. So this theta 1 can be written as minus theta 1. If it is in negative this direction, can be written as minus theta 1. So this is from minus theta 1 to this end. This is in counterclockwise or anti-clockwise. This is nothing but theta 2. We don't know what is the angle, we don't know how much is theta 1 and theta 2, but we are just taking from theta 1 to theta 2. We have to vary to complete all these charge, or these complete charges, or this complete charge distribution, so that we are giving the limits from minus theta 1 to theta 2. Okay, so it can also be written as k lambda by z into, here is a minus sign is here, so we can give lower limit first. Cos of minus theta 1, cos of minus theta will be theta only, so cos theta 1 minus cos theta 2. So this is the result of x component of electric field at an arbitrary point due to a linear charge distribution. Okay, that's the x component of electric field. Then we will move to y component. We need to find the y component also. So what is the expression for y component? Already we have seen that the expression for y component dEy. dEy is equal to dE cos theta. dE cos theta, which is equal to, what is dE? dE is same. dE is k dq divided by x square plus z square. This is dE into, what is cos theta here? Cos theta is nothing but here. This is theta. Cos theta will be equal to z divided by root of x square plus z square. Okay, then it can be written as dEy equal to k into dq can be written as lambda dx. dq can be written as lambda dx. Then z divided by x square plus z square whole raised to 3 by 2, which is equal to k lambda z plus k lambda z, then dx divided by x square plus z square whole raised to 3 by 2. This is dEy. So if we need to find Ey, Ey is the integral of this. Integrate, just integrate. So just integrate dx by x square plus z square. This is also a standard integration and its value will be k lambda z into its value will be equal to x divided by x square plus z square whole raised to 3 by 2. Sorry, x divided by z square into x divided by z square, and this is the standard integration and its value is x divided by z square instead of a here is z is here, so z square x square plus z square all raised to 3 by sorry, not 3 by 2, 1 by 2, 1 by 2. So this is the answer, 1 by 2. So it can also be written as this is there is a z square here and this z can be cancelled, so k lambda by z into x divided by x square plus z square whole raised to 1 by 2, which can also be written as k lambda by z. What is this? X divided by x square plus x divided by square root of x square plus z square. So from the same figure, from this figure, this is z and this is x and this is root of x square plus z square and this is theta. So x divided by this term will be opposite side by hypotenuse, that is nothing but sine theta. So this is sine theta. Sine theta from similarly minus theta 1 to theta 2, which is equal to k lambda by z into substituting the theta 2 here, sine theta 2 minus sine minus theta 1, which is equal to k lambda by z into sine theta 1 can be written first. So minus here, minus of sine minus theta. Sine minus theta is minus sine theta. So minus of minus will be plus. So theta 1 can be written first, then plus sine theta 2. Sine theta 2 is same and sine theta 1, how the sine theta 1 came? Here is a minus sign and sine minus theta 1 is minus sine theta. So both minus will be plus. So this is another expression. So for an arbitrary point, you just remember these two formulas, that is Ex will be equal to k lambda by z into cos theta 1 minus cos theta 2. Theta 1 is angle measuring in this direction, here this angle, and cos theta 2 in this direction. And Ey is equal to k lambda by z into sine theta 1 plus sine theta 2. So these are the two expressions you need to remember for further applications. Okay, we will see some cases from these equations. So you have to remember these two equations. These are important, Ex and Ey. We'll see how the importance is. That is, for a thin rod, just consider for a thin rod, that is x component and y component we got. So this can simply be rewritten as, for a thin rod, that x component can be written as E parallel. Obviously we will take a rod like this, so x component means it is parallel component. E parallel equal to k lambda by z into cos theta 1 minus cos theta 2, and y component means E perpendicular component. E perpendicular is equal to k lambda by z into sine theta 1 plus sine theta 2. These are the two cases. Then if theta 1 equal to theta 2, just take first case, if theta 1 equal to theta 2. What is meant by theta 1 equal to theta 2? At the center we are considering. Then it will be always theta 1 and theta 2 are same. If theta 1 equal to theta 2, then what will be the result? E parallel will be equal to cos theta 1 minus cos theta 1, or theta, if both the thetas are equal, then it will be equal to 0. And what about E perpendicular? E perpendicular equal to k lambda by z into sine theta 1 plus sine theta 2. Sine theta will come. Okay, sine theta will come. If theta 1 equal to theta 2, sine theta plus sine theta will be equal to sine theta. So these are the results if theta 1 equal to theta 2. Then some applications are there. What are the applications? First one is for an infinite thin rod. For an infinite thin rod. For an infinite thin rod means what? It is infinity. The rod is infinite. So if we are considering a point here, means what will be the angle theta? Theta 1 and theta 2 will be 90 degree, because we can't take theta 1 here. If it is here, okay, there's an angle. If it is here, there's an angle. If it is here, there's an increasing angle is increasing. And if it is infinity, angle will increase to maximum up to 90 degree. So theta 1 equal to 90 and theta 2 is also equal to 90 degree. So what will be the result? E parallel will be equal to theta 1 and theta 2 both are same. So parallel will be 0 and E perpendicular will be equal to k lambda by z into sine theta 1 plus sine theta 2. If both are equal, it will be 2 sine theta only, 2 sine 90. Sine 90 will be 1 only. So it is 2, 2 into 1. So 2k lambda by z. So this is the result of an infinite thin rod. A rod infinite, which is infinite at one end. A rod, second application is a rod which is infinite at one end. Infinite at one end. It will be like this. Infinite wire, infinite rod, infinite at one end, which means we are taking a point here. There is a point here, and while considering this point, this position, this angle will be, if it is extending to infinity, if this rod is extended to infinity, this angle may be equal to the maximum value, it will be 90 degree. Okay, so theta 1 equal to 90 degree and theta 2 will be simply equal to 0 degree. So by substituting in E parallel and E perpendicular equation, E parallel will be equal to k lambda by z into cos theta 1 minus cos theta 2, which will be equal to k lambda by z into theta 1 is 90 degree, cos 90 is 0 and cos 0 is 1. So it is equal to k lambda by z minus k lambda by z. What about E perpendicular? Which is equal to k lambda by z into sine theta 1 plus sine theta 2, which is equal to k lambda by z into sine theta 1. Sine 90 is 1 plus sine 0 is 0, which will be equal to k lambda by z.